This unit is going to focus on some of the different transformations you can do in geometry. And the word transformation really means change. So we're going to look at how we can change figures into the same shape in a different location, or a similar shape, or stretch or flatten shapes. So we're going to look at lots of different shape changes. So a couple of different vocab words we need to talk about. An image is the figure after a transformation. And it's important to know these vocabulary words because a word problem may say something about the image or the pre-image, and you have to know which one is the first figure and the second figure. So a pre-image is our original figure, so the first figure. Okay, so pre-image is where we start, and image is where we end up after a transformation. Now, notation in geometry you've come to expect. That's a very important thing. Our pre-images will have our normal triangle ABC, or quadrilateral DEFG. It will just be our vertices like normal. After a transformation, our corresponding image points would be something like triangle A prime, B prime, C prime, or D prime, E prime, F prime, G prime. So that little prime notation right there is what indicates that that G prime is where the figure G went. It's the new G. If you get fancy and you take a pre-image and you move that in some sort of transformation, then we get things like A double prime, B double prime, C double prime. So this A double prime came from A through A prime to A double prime. So it's a way of tracking and knowing how many transformations you've done and what points correspond to what other points. Now, another key vocab word is the line of symmetry. And again, this is something we've used before, and I like to call it the mirror line. It's the line which cuts a figure exactly mirror image. I could fold it in half on this line, and that would match up with this side exactly. So it's going to cut it in half. And we've seen that with parabolas, we've seen it with other shapes, that we can cut them in half. Sometimes figures have more than one line of symmetry. This rhombus has 2 lines of symmetry. This equilateral triangle actually has 3 lines of symmetry. So that is a unique figure of an equilateral triangle. Now, what kinds of transformations can we do? The first kind of transformation is called a reflection, and this is a flip over a reflection line. Okay, now the reflection line can be any random line, any random horizontal or vertical line like y equals 2, x equals -5, or we can reflect over the x-axis, the y-axis, some special lines like y equals x, y equals -x, or any horizontal or vertical line. Now, these have rules. These you can do by sight. So you'll use the graph and figure out how to reflect it. So in this case, you can see here's my reflecting line. It's one of those random lines in space. Here is my pre-image. Because of the notation, here is my image. So this point B went to B prime. Now, one of the things we're not going to really get into, but one of the unique things is from the reflecting line to each point is the exact same distance and perpendicular. So C to C prime is the same distance from this point right there, and perpendicular. A through the line to A prime, this side to this side is the same distance, and it's perpendicular. So if we look at this example, and this is reflecting over the line x equals 4, so vertical line through 4, where would this point end up? Well, J is 1 unit from the line, so J prime ends up over here. Think about folding this and ink blotting triangle JKM across the red line. K is 1, 2, 3 units. K prime will go 1, 2, 3 units. M is 1, 2, 3 units. M prime will be 1, 2, 3 units. And when you connect those points, you end up with the exact same figure. So reflections give you, they do not change the size or the shape. So basically you make congruent figures, if you remember that from an earlier lesson. They just change location. So you're going to have the exact same figure in a new spot. Now, as I mentioned, there are these specialty lines and they have rules. Now, the rule is written T of xy, that's your original, will become T prime of, leave your x alone, do the opposite side on y. So if we look at this, I am at -6, 3, -4, 5, and -3, 1. Now I could use the reflecting line rule like we did. Here's my reflecting line. If M is here 1 unit away, that means M prime is right there. What is that going to be? -3, -1. So you can see that I have the exact same x coordinate and the opposite sign. So I can go ahead and use my rule D prime 1, 2, 3, 1, 2, 3. My rule tells me it should be at -6, -3, and it is. And 8 should be at -4, -5, -4, down -5. H prime, -4, -5. And I have reflected my figure over the x-axis. Tune in to part 2 of this video for the rest of the rules.